This is Klangmeister. I'm Chris Ford. So I've been interested in music programming for a while now, and one of the key things that happens is when you show people making music with code is they get really excited about it. And that's great, right? Because you want to teach people about learning about music, learning about programming. But the trouble is that the first question you often have to ask people who get interested in this is, do you use Vim or Emacs? Right? So you have people who, maybe they aren't professional programmers, maybe they're just hobbyists, or they're just people who are smart but haven't really learnt programming. Maybe they are professional programmers. But the most common answer to the question of do you use Vim or Emacs is no. Right? So the people in this room are not at all representative of people who might want to use stuff like that. And that's a bit sad, right? So it's very easy for us to build things that we can use and that we can set up that other people can't do. And that's not to mention, the next question you might ask them is, do you use Mac or Linux? And again, the answer is probably no, right? So getting set up with this stuff is a really big challenge. And so my goal with Klangmeister is to make music accessible. So that needs to mean a couple of things. One is you need to be able to install this stuff and get going really quickly. You need to get kind of positive feedback really quickly. So if you're someone who's interested in doing this, you don't want to have to invest hours and hours of your life before you get something meaningful back, right? That's kind of irrational of you. Until you've got that feedback, something happening, something coming out of the speakers, then why would you spend your Saturday messing about with this? And then finally, the form in which the music's presented has to be kind of expressive and clear so that you actually understand what's going on. So this is in the browser, right? And this is on a new computer, lent to me by my friend from the previous speaker. So what Klangmeister does that is not unique but a little bit different is that it does these things in the browser, right? So there are other browser-based synthesis tools available, but I think Klangmeister has some interesting properties. So you should be able to just load up that URL and press play and be rewarded if you're interested in this. You shouldn't have to install plugins to Emacs, Vim. You shouldn't have to feel ashamed that you're using Windows rather than Linux and adapt command line tools. You should be able to just get something back. And maybe in the long term, you'll be interested enough in this to invest in learning powerful editors like Emacs, learning other operating systems. But you're not going to invest that time until you get something back for it. So the basic Sorry? It does work in other browsers. There's just a bug in Firefox at the moment that produces a slight clicking sound, so it would work fine, and if I hadn't mentioned it there, then it probably would be okay. Basically, what Klangmeister depends on is the web audio API. So these actually, I have tested it does work in Safari, Chrome, Firefox. Just Chrome is the one that seems to be the most stable at the moment. I've actually considered removing that message because, given how the progress of the different browsers. So there's probably two pieces of technology that have happened recently that have enabled Klangmeister to be built, because it's not that sophisticated an application in itself, but the web audio API means that there's synthesis that browsers support. So I guess eventually browsers will support APIs for everything, but quite conveniently for me, they support things like the creation of sine waves and filters. So you don't have to have something like SuperCollider running as a server to farm out things, it's just right there. The other thing, which is maybe a bit more specific to my interests, is that ClojureScript, which is a Lisp that compiles to JavaScript, is now bootstrapped. So it's possible to compile ClojureScript in ClojureScript, which means that it's easy to have an actual proper general purpose. I can hear someone Klangmeistering in the audience. It's possible to have a general purpose programming language running and compiled in the browser. So we don't have to either use JavaScript and eval it or kind of invent a new language ourselves. We can take advantage of the good work done by the people who are building ClojureScript. So one thing to note is it is in fact compiling on every key press, right? So this is something that's, it's pretty fast. If you want people to play around with this stuff, it needs to be interactive. So every time we're actually just changing anything, it's recompiling and re-evaluating the music. So the way that this kind of DSL works, it's not magic. It is just regular ClojureScript code. And what it's doing, it's outputting a data structure, which I can show you in a second. But basically, each note is just a discrete event that has a time, a duration, and a pitch. So very simple data structure. And then the whole program is built just out of functions that operate on that data structure, that underlying thing. We can just make changes. Oh, there's also a bit of documentation, which is nice. and get different notes, right? So you should be able to, part of learning and being interested in these things is that you should be able to experiment, right? But one thing to note in terms of how this model of music works is that this key is not a special data structure. That's just ordinary function composition. That's what comp is. And for example, E, I should have done the arithmetic in my head, is just a function that adds to a number. So if you remember early on with Beethoven, we talked about, or Jay talked about having kind of relative scales basically, where you can just write your music relative to where the scale starts and don't have to, know the fact that E is something like 74 or 75 in MIDI scale. So all that sharp is, as it happens, is just an alias for the closures version of plus plus. So what happens here is we specify our pitches in terms of where they are in the scale, and then we just apply a function to it. So we've just done kind of coordinate transformation. Oh yes, question? Yeah?
Does 2 mean 2 semitones or 2 notes?
Very good question. So it means 2 notes within the scale we're talking about. So maybe I can produce another piece of code. Range. Oops. Let's say we have 8 notes, and we're going to range from 0 to 8. Let's make it a little bit slower so we can actually hear. So we just played the minor scale. Let's play the major one. So that's not the chromatic scale. Those are actually the notes within the scale. So I think part of the beauty of this way of representing music is you can, if you play the natural numbers, you get something that's coherent within the system. So we've kind of, if you think of semitones that are not in the major scale as being kind of illegal, then in a way this codification makes that illegal state unrepresentable, you could say. Of course, if you do actually need to get back to it, you can use like fractions and that works, but it basically means that we're operating at the level of abstraction that's appropriate to the piece of music. I said that I'd show you what the data structure looks like. Maybe that's if I can, I'm not even sure where square brackets is on this keyboard, so I might not actually do that, but basically it's just a sequence of coordinates that have time, pitch, and duration, and so all where really is kind of a kind of functor that goes into each note in the list and looks and focuses in on the pitch. So you could lens functor something like that. So one of the things that I think Klangmeister does pretty well is it doesn't just let you compose melodies; it lets you compose synthesizers. I hope this won't be too loud. So this piece of code defines a sine wave of 440 hertz. Actually, probably the best thing to do would be if we can go down a little bit, you can see that we can connect it to a gain, so it's going to be quieter now. And at each point, this isn't a static example. If someone is reading through this and they want to understand what's going on, they can, they can adjust the gain to hear it louder or make it softer or whatever. So basically this connect is just a higher order synthesizer function that connects the output of the sine wave into the input of the gain. And again, this is real code, this is running in the browser, and it's turning into web audio calls. Now, a lot of people in this room probably understand quite well a lot of the elements of music, but I'll still run through it quickly. So connect isn't the only combinator we have, so you can connect synthesizers in series, so the output of one is the input to the next. We can also add waves together, so you can kind of hear that beating effect. So those of you musicians might know that that's how, for example, you tune a guitar by hearing 2 waves that are almost in tune interfere with each other. So if it's really close together, the beat slows. So you can hear maybe a vague volume. If we go a bit further apart, then that should go a bit faster. Right, so that's just a pattern of waves falling in and out of phase, so they're reinforcing to double the volume and then cancel each other out. Oh yes, a question? Yeah.
What program did you specify how long it runs?
Very good point. So basically, how long it runs is just something for these particular examples of synthesis. It's just hard-coded in. So later on, we'll put the two things together. You'll be able to write your own synthesizers to play for whatever duration. But here, just to demo it, there's basically a duration of a couple of seconds that's hard-coded. Very good point. No hiding things from this audience, I guess. So we can also define envelopes, as you might imagine. So if you're not familiar with what an envelope is, it's a way to shape the sound. So in a percussive envelope, the first number defines how long it takes for the note to get to maximum volume, and the second number means how long it takes to die away again. So typically, percussive, if you're actually like whacking something, you'd expect it to take a very short period of time to get to maximum volume, and then a longer time to die away. And if you reversed it, you get this kind of effect that sounds kind of like a George Harrison kind of reversed solo. Right. So you're hearing the sound getting loud and then dying away. So it's not a very natural sound. Like natural things that you play don't really work like that, but you can produce those effects with synths. So just got a little bit more to talk about with how the synthesizers work. So we do have other kinds of waves. So a square wave, you know, we have triangle, sawtooth, all the standard ones. And what that means is the different wave shape, effectively, if you know your kind of sine wave mathematics, basically it just means you've got different harmonics. So you've got the same base frequency, but square wave, triangle wave have other higher harmonics operating in the sound, so it produces a different sound quality. You can also do things like filter, so we can just connect in a filter, which this low-pass filter will cut out high frequencies, so it should make a kind of a more closed-in sound. If we change the low-pass filter, we've got a more opened-up sound because the higher harmonics are still present, and you know, you have your high-pass filters as well, which are just the reverse. So now we're just keeping the high frequencies, cutting out the low frequencies. So if you know your synthesis, then you can use these different elements to put together instruments. And even if you don't, you can still put things together and just see what sounds good and what doesn't. The final thing is, just like Jay mentioned in the morning, you might actually want an ADSR envelope. So that's a slightly more complicated envelope. So rather than a percussive one, which basically just looks like a tent, a lopsided tent, an ADSR has an initial kind of loudness before dying down and then sustaining a note over time. So if you just have a percussive, you can't really do notes of different durations. You're just whacking the thing. Whereas if you have ADSR, you can hold notes for longer. Cool, so that's how you put together synthesizers. What I just quickly wanted to do, given the present audience, is I just wanted to talk a little bit about how that's implemented. So, you know, you could tell that as we were working with our synthesizer, sound wasn't happening as we edited the definition of the synthesizer, right? So the code to produce sound wasn't being executed as we were going along. So, you know, how do we do that? Well, there's two data structures that are relevant to this. The first is that synthesis can be thought of as a graph. So hopefully you can read that there. So the way Klangmeister works is it works with flow graphs. So graphs with at most one entry node and one exit, yeah?
Could you go front a little bit?
Let me see.
Edit.
Sorry? Oh, edit, all right. Thank you. You're just suggesting how to increase there's a settings. But it doesn't. Sorry?
Configure K. We're just hitting control.
Right. Fonts and colors, right. Font, let's make it bigger.
Oh, you could also just press Control plus.
I possibly could, but why do it the simple way when there's a more elaborate way available? Yeah. So I won't spend too much time in the editor. I just want to give you a bit of an insight into the implementation. So first of all, we've got the idea of a subgraph, which just has an input and an output. This is ClojureScript code. So the nice thing about things that have most one input and output is that kind of graph is tractable. It's easy to work out how to kind of take two of these graphs and put it together to make another graph. So we can either connect them in series, and you can just connect the middle nodes and you've got this overall graph, or you can connect them in parallel and have them both connected to the same output. So it makes it very easy to design a coherent API over the top. So the web audio API isn't really designed to have general purpose combinators. It's fine for doing mutable JavaScript to build individual nodes and individual things, but it's not so good for that kind of higher order stuff. So we've got that structure of the graph node. And the second thing that's relevant is that we actually, I'll see if I can find a good example. Maybe the gain node is a nice simple one. So what a synthesizer actually is it's not an actual node, it's not an actual synthesis graph. It's a function that will return a synthesis graph when you tell it what time to play, the duration of the note, and the audio context to play in. So basically what that means is it is a pure value. It's a reader in functional programming terms. And because it's a reader, that means that it's an applicative instance, so we can still do things to the output graph of the readers and add them together and do whatever, but in the end nothing actually happens. All the side effects are contained until we finally decide when we want to play it and for how long. So that's how kind of implementation wise we're able to do things like this in a purely functional way, despite the fact that the underlying web audio API is mutable. Once you've created a graph and stopped it, you can't use it again. You can't you have to kind of actually mutate nodes to plug them into other nodes. Cool. So I'll talk a little bit more about composition now. So just to be a bit more explicit about what's happening when we build a phrase of notes, we have the durations of the notes, and we have the pitches. So basically just this is how it zips together to form those little maps. Here we're specifying the pitches in MIDI. Right, you might recognize that little fragment. Very nice, very nice. Well, you don't need the synthesis at all, right? So we can use different ways of putting melodies together. So what then does is it puts one melody after another one. Yeah. So that is a bit slow. Actually, probably the next thing I'll show you rather than the speed is you can also, of course, play two melodies at the same time. So this is really just quite geometric transformation. In order to, if you can think of it as like a graph of Western music notation, then it's just translating one so it happens after the other. Sorry, I'll reverse. Translating it so it happens after. And with is superimposing the two at the same time. All fairly straightforward. We can do things like playing things multiple times. I'll spare you that. And we can also do things with a tempo. So basically tempo works very similar to scale. So what I said, scale is a function. So some people model scales as sequences of values. The way that I model scales is as a function. So it translates the index into where in the scale. The same thing applies to tempo. So if you have a notation that describes things in terms of beats, what you need is a function that knows how to translate which beat into when it happens. So it's just it's basically a scale function but applied to time and duration rather than to pitch. And so we can start, so beats per minute 90 is just a simple calculation, so we can start to play things in a tempo. I wonder how fast we can reasonably go before the browser starts complaining. Oh, that's all right. And finally, we can reintroduce this idea of scale. So rather than having to specify things in terms of MIDI pitch, as I mentioned, scales are a function. So if we specify them as natural numbers within the scale, then it means that we're kind of modeling the music more thoroughly. So if you specify things in terms of MIDI pitches, 72, 74, 75, especially to someone who doesn't know what's going on, that's really kind of arbitrary. Someone needs to work out in their head, oh, okay, 73, now that's not a semitone that's in the C major scale, so if I've typed that, I've made a mistake. Whereas if you can actually model things as natural numbers, I think it actually explains what is going on with the music a little better. Cool. So those are the two main components of Klangmeister, right? So there's synthesis, you write code to combine synthesizers, and there's composition, which lets you put melodies together. And one of the key design decisions with Klangmeister is that explanation that we've seen so far, that tutorial, is Klangmeister. That's kind of the first class thing that you see when you arrive to it. So something that other music coding or other pieces of software might do is that you arrive, you see the main pane, and then you might have like a "so you're new here" link to click off to the side. The idea is that because Klangmeister is about accessibility and about teaching, that's really the focus. And there is a little bit of stuff where you can actually perform, but that's in a way the bonus at the end of the class. I might just see if I can load up an example I've pre-prepared, rather than just the default one that comes, which anyone can get. That wouldn't be special for you. Cool. So we've just got a nice little bit of bonus that because we're in the browser and we're using functional programming to also, as well as play the notes, to display them. So the basic premise of how performance works in this musical system is that what loop does is it plays the notes that are defined in the code pane, and then only when we finish the loop does it re-dereference that. So basically you can edit what's going on, and the loop will just pick up what you're doing as you go along. So if you just... So this is just a piece and being animated as we're working on it. So we can edit our synthesizers and things like that if we want as we're going along, and next time around the loop it'll pick them up. Right, so there's a low pass filter that I'm actually inputting a sine wave to. And if I decide I want different instruments, I can do that. Alright, you hear a slightly different synth now. It's quite nice. And so basically the way that you sequence things together, I've discovered in terms of coding styles, you kind of define all your individual parts and you can comment them in and out to get different effects and edit them as you go along. So I might get rid of this little comment to introduce this kind of semi-vocal part. Alright, it's kind of robotic. And the way this is all produced is just using ordinary closure script. So see if I can find a good example. But so using just kind of ordinary sequence functions. So repeat 7 is just an ordinary closure function, nothing to do with music, that just outputs an infinite sequence of -7s. So that's a way that we can output a particular pitch. Alright, so that's probably getting a bit repetitive, so we can introduce a variation. Oh, I won't hear it right now, I have to go around the loop again one more. Alright. Variation. And all these variations can be written just by writing code that manipulates that data structure. So what we're going to do this time round is we're going to go into a whole kind of variation, or a whole kind of alternative section to the piece. So it's kind of quite a lot of notes to find now. So my aim with kind of showing you this piece is to show that this kind of way of composing music does kind of scale up. You can write basically whole pieces. And I would typically, if I was trying to compose something using this, what I would be doing is mixing in and out the different sections until I was happy with it. And then eventually you can just sequence the whole thing. So you can just, in the end, have an entire piece of music that you can play to end to end. How do I do semicolon? It's an unexpected difficulty. Get louder. So we're just about to loop back to the start. Dominant 7th chord to lead us back to the root. Alright, back to our robot. So we're going to finish up this. Oh, no, we're not. Soon we're going to finish up. Right, so final time round. You know, and if you're interested in the geometric interpretation of the notes, well, you can look at the notes and see how it works. Alright, we should hopefully resolve onto chord now. Alright, so that's a chord that hasn't been played throughout the piece, but it's kind of the one that the piece was wanting to resolve at. Cool, so basically this way of putting together synthesizers and notes can be done in the browser by someone who's interested, but you don't really need to start at this point. This is what you can work towards. And one of the things that I definitely want to take further, and I've done a bit in work outside this presentation, is extending this concept more to musical systems that aren't European. So this is quite a Eurocentric point of view. The code here was originally written not for Beethoven, but for Bach, as it happens. And that's where Klangmeister is a reference. But there's a lot more rich musical systems that, especially without the shackles of Western music notation, we as programmers should be able to model. So I guess that's it. Thanks very much. Do we have time for questions?
Well, we'll do all three.
Okay. Yes.
So, Martin Dybdahl at University of Copenhagen. I'm writing a couple of code classes in Copenhagen. One of them is focused only on music programming.
Yeah.
So this is really
Cool.
interesting to me. But one of the things you face when you're teaching programming is to how to do collaborative projects where several kids or students can work on the same project instead of sitting each with their own laptop looking into and not talking with each other. So, and what we're trying to do is make each of them, one build a drum machine and one building some melody and so on. And so I was wondering if you had an idea if you could sort of build a system on top of this where you can control the metronome and then each computer can...
So the question is about, okay, if you've got lots of people who are using this, how do you keep them in time, basically? And I guess that's fundamentally the question about distributed systems in general, right? You don't have a universal clock. What do you do? And if you look at a lot of actual musical practice, whether it's conductor through to signals that musicians use between each other, that's actually kind of a fundamental problem even for actual musicians, how to converge the same timing. I don't actually, certainly this this has no server-side component, right? This is just some static JavaScript files sitting on GitHub pages. I think it's a really interesting challenge. I'd be, if you manage to come up with something to solve that, I'd be definitely fascinated. There's probably some good enough solutions, like maybe you can't achieve exact clock synchronization, but you can come up with a way of maybe the human could give good input, like they might have their own clock going and then they can kind of slow it down or speed it up to synchronize with the other system. Perhaps that's kind of like what DJs do when they're synchronizing records. You've got the human who can actually achieve the synchronization. But it's a very good question. Yeah.
Yes. So you can make synthesis and you can make sort of MIDI style notes. How do you combine them? Can a sound that is synthesized and become a note and you can use it as a note, or these are two separated worlds?
So there's two different models. Basically, the way that you put it together is you can define a function that knows how to interpret a note. So certainly other systems, like I'm aware of, like say Tidal for Haskell, has a unified abstraction between the synthesis layer and the composition layer. This doesn't. Maybe it would be a good idea if it could. But basically you define your synthesizer as almost like your templating layer in terms of web programming, and it just is a way that you interpret those series of notes.
Still, they're sharing the same timeline.
Sharing the same timeline, yes. Yeah.
One more.
I'm happy to chat afterwards if anyone wants to ask me further questions. Yeah.
I originally had the same question like Martin.
Yeah.
I have another question as well. So you made it interactive by having a graphic visualization. That's great. Can you make it even more interactive by finding, say, little buttons that can be clicked during the play that can alter what that the program can react to and stuff like that?
Right. So can you define kind of additional kind of flourishes and inputs to change effects as the program's going on?
Gesture recognition.
That sounds like a pretty cool thing to do. I'm sure, given capabilities of browsers now, that there would be ways to do that. Maybe you could have a filter that you could raise or lower throughout the song. That's kind of a common electronic dance music kind of thing that people like to do. I think that's a really good suggestion. I mean, right now, I think effectively the kind of immutable functional way it's doing is a bit too clunky to easily do that, because it basically takes a snapshot of the state of the code, plays it through, and takes another snapshot. Whereas I think you're talking about giving the performance a bit more life by actually having other ways of intervening continuously.
Yeah. Like having a button, and every time it's clicked, it switches between two functions or something.
Yeah. I mean, certainly you can model non-determinism right now. It's just explicitly by writing functions that choose one way or the other. But yeah, that's a really good suggestion. Thanks.
Thank you.
Cool. All right. Thanks, Michael.